don't know why my passwords have to be so complicated. Back in the old days, I could just make my password pussy fart and sometimes add the number 1. And if I wanted to get really tricky, I'd put the exclamation point on the password. No hacker would ever guess that I would do that. But I mean, let's be honest. That's exactly the first thing that hackers are going to try because that's exactly the first thing that people think of, right? So let's start off really basic. What is brute forcing? It is kind of what you expect it to be. It's right in the name, right? So we know that passwords tend to have a couple of different requirements. You need to have 8 characters minimum, 1 capital letter, 1 lowercase, 1 number, and 1 special character. If I could type, that would be amazing. But those are, the standards that we're used to. If you're making a brute forcing program, chances are you're catering it to the specific application or service that you're trying to get into, and you know the requirements behind passwords. Let's say, for instance, that you only had to have a capital letter and a lowercase letter, and you had to have at least 8 characters. So it knows that, right? Well, what you'd kind of program your brute force program to do like A. Well, that didn't work out. Let's try out A, B. That didn't work out. C. And you'll continue that ad nauseum until you reach all Z's, actually more specifically, capital Z's, because you'll work your way through the capital letters as well as the lowercase letters. So let's kind of take a look at how that would actually look in terms of like a time scale, shall we? So using the example that we were just talking about, if we just had just letters, uppercase and lowercase, there's 26 letters in the alphabet. Multiply that by 2 for upper and lowercase, which gives us a total of 52 possible characters to use. At a minimum of 8 characters for a password, it's going to give us 52 to the power of 8, which is about 53.5 trillion possibilities. It's going to take about 848 years to break that password, assuming that the password is all capital Z's and you're starting from the beginning and you're going in order. The next step is, of course, going to be letters and numbers. So capital letters, lowercase letters, and a number or multiple numbers gives us now 62. Uppercase, lowercase, and numbers 0 through 9. That's 218.34 trillion possibilities for passwords. It's going to take 3,462 years. You can check my math if you want to. It's genuinely that long. And finally, we have kind of the standard for passwords nowadays, which is going to be letters, capital and lowercase, numbers, and the special characters like exclamation points and things like that, which brings us to usually about 94 characters. So we run that math again, which is 6.1 quadrillion possibilities. And once again, at about 120,000 guesses per minute, we're looking at 96,622 years, plus a little bit. So a lot of people will take a look at this and be like, well, that just means that nobody's ever really going to guess my password. Like,